they can also have a spin property. So, proton and neutron. You can notice the fact that electron is a charged particle, proton is a charged particle, neutron is a neutral particle, yet it can have a spin. Okay? So, if we have a proton here, it has a spin which we can represent something like this. So, let us assume that this is the spin. Let us suppose that it is spinning in this particular direction. Then when it is spinning in this particular direction, we can say that this is the axis of the spin. Okay? This is a visual for your imagination. Okay? Right, yeah. So, this is the axis of spin. Let us suppose this is the direction of spinning. So, now the next question is, if the proton has a spin and the neutron has a spin, does the nucleus as a whole have a spin? So, let us try to understand this, right. Okay. So, what is the nucleus? It is a combination of neutrons and protons, right. So, if a proton and a neutron, which are the nucleons, have spins, now the question is, does the whole nucleus spin? So, for this purpose, let us start by assuming maybe. Okay? So, let us assume maybe. Now, let us try to define a condition for this. Okay? So, what are the conditions possible? Now, let us consider a condition uneven number of protons, uneven number of neutrons in order to have a spinning nucleus. Okay. Remind me to take the attendance, okay? Okay. So, again, a nucleus can't spin just because its components are spinning. Okay. So, the question is, why do we need uneven number of protons or neutrons? So, this leads us to the question, why do we need an uneven number of protons or neutrons. Or we can say, why do we need an uneven distribution of spin states? Or why do we need an uneven distribution of spin states? Okay. Now we can try to explain this. What happens if we have an even state and what happens if we have a odd state? Okay. Teaching now is more about handling so many things at the same time. Okay, so if we have an even state, we may have the neutron spinning in one direction. So this is one possibility. And the proton spinning in the other direction. So let us say this was the nucleus we had with the nucleons, the protons and the neutrons, and let us say the neutrons are spinning in one direction and the protons are spinning in the opposite direction, like this. Now, you may imagine how these spins may cancel each other, right? Okay, so if they cancel each other in this figure, even though the individual components are spinning, the nucleus as a whole will not spin. Okay? So in this example, even though the nucleons are spinning, but they cancel each other and therefore the nucleus will not spin. No, this is one case. This is one scenario. We are going to consider different scenarios. देखो, these are not things that you can see. आप देख के नहीं बता सकते कि yes or no.
We can only tell about their resultant negative.
Yeah, you can, there are many ways that people have tried to study this using different tools, using indirect methods, using different kinds of thought experiments also, right? When nothing works, then you go for the thought experiment. So there are different ways. You try to relate it to the previous knowledge that exists, and then you try to explain it, and then you try to understand it. ठीक है ना? So that's what we are trying to do at the moment. Okay. We started with the simple example of the electron, है ना? Electron is still easier to work with. उसका आपको charge नजर आ जाता है. But nucleons are harder to work with. ठीक है ना? Especially a particle like a neutron जिस पे charge है ही नहीं. So you have